So just before I start, are there any QAs here? Yes. Are there any programmers in Unreal Engine? Okay, so the lecture is about everyone, but these people will understand my pain. Okay, so the topic is automation game testing in Unreal Engine 5. We will take a look on automation testing, what it is, how it differs from manual testing, and some practical problems in games. We'll be looking at Unreal Engine 5 and what tools does it have for automation. I'm Ivan. I'm manual and automation QA in Kipi, and I'm also a game designer there. Okay, so on the subject of testing, what is testing essentially? You have specifications on how a product might behave, what is the intended behavior, and you test that, and you test your product to see if it consorts to these specifications. In manual testing, you're executing specifications on a certain list by hand and look for some defects, some issues of that list. In automatic testing, you're writing a script, you're executing that script on a framework, and check the results if there are any problems. Okay, so manual testing requires a lot of attention to detail. You have to check the things that you are sure, the things you are not sure, and spot some other issues in the process. So, for example, if you see, if you're tasked with checking out the graphical components of the game, and you see the character gets stuck somewhere in the map, you have to turn your attention to how the map is designed and report that as a problem, regardless of the subject that this isn't the specific topic you're testing. It requires periodical reiterations. So after checking a product once for this month, you have to check it again after a certain period of time to see if the programmers haven't introduced some kinds of errors there. It's great for visual tests, any tests that require graphic, the person to look at how the game behaves and to spot any visual issues. And it does not require a lot of setup, does not require usually deep understanding of how the product is programmed. In automation testing, you have to know the tool you're working with. In that case, the automation framework. You have to know how to write scripts in that framework, and you have to have the time to implement those scripts. So, for example, in web testing, you have to you don't have to know the specific web applications, the details of the web application you are testing. You just have to have a good understanding of Selenium to perform these tests. Automation testing is a good option for regression to see that that you haven't introduced problems in the newer version of the code you're testing. It is very good for performance and content stress testing. It is very, very accurate, more accurate than manual testing because it eliminates the chance of a human error. And the tests, as they are scripts, they run fast. The test cycles are much shorter than an average manual test cycle. And there you can run those tests, for example, on the weekends, late at night, and see the results when you are available in the office again. So the problem in games, compared to other software products, there are there are specific issues that only games tend to have. One of these issues is physics. Uh, in the sample I've provided there, we have a snooker table, billiard table, and if a test has to verify whether or not a ball stands in a specific position, that is very hard to implement after we have taken the shot. It's very hard to implement because there are a lot of variables involving physics, whether the ball should hit another ball, whether it would hit an edge of the table, and because of that, the end position would be quite unpredictable. Another thing that only games tend to have is randomness. While testing software products, they behave quite predictably. In games also, you often have problems of the sort that you don't know what to expect after a specific event with random results might happen. In our case, we have an archer that shoots another target, and if the archer has a variable damage and the target has less health than the maximum damage, then in one case, the target would stay alive after the shot, with all of the consequences of that. The user interface will be reflected, the color of the health bar would change, the target will stay alive and produce maybe a notification sound that it has been hit. So this event triggers game systems that are quite specific in that case. In the case that the target dies, it triggers other game systems. For example, that the target should die, the player should be notified, maybe he would gain experience, and the target dying would have to despawn it and would have to remove its collision box. These are very, very different game systems, and that's why when we are creating automation tests, we have to check for all of these scenarios. So the test would become quite more complex. And the other thing that really, really increases the possibility space again in games are the branching choices. Whether or not it would be what would be your next location in the game, like in the Slay Spire example. What skills would your character have? Like in the Diablo example, what items would you have, and what choices your character has taken in the game, and how he has moved the narrative forward. These all create a lot of options, a lot of possibilities that are virtually impossible to explore with a single automation test. In that case, it's better if you are the tester to test more limited gameplay scenarios, for example, with limited set of skills, whether they are working correctly. And even then, you cannot be sure of the different possibilities. For example, one tier 100 skill would, after interacting with one tier 1 skill, would break the game. You cannot be absolutely sure of that, and you have to write impossibly large number of tests to verify that. So, what can we do? Don't be scared. We can test limited gameplay scenarios. So we can, in the case with the physics, we can test the movement of just one single ball. We can then test how it would react after hitting another ball. And then we have to make the example more and more complex. But in some cases, you will still not be able to export the full game. It can also be combined with manual testing. So, as we said in the skill tree example, we may not be sure that every skill interacts with every other in the perfect way, but there comes the manual testing that can verify that it isn't breaking. So you receive a report that one skill interacting with other breaks the game, and you investigate it, then prepare an automation test that reflects that exact scenario. It's great for regression and performance tests. More details on that later when we discussed how it is handled in Unreal. And for API testing. Yeah, this is Unreal. This is the session front end from which you create, it's the starting point for all of the tests. It contains Unreal Engine specific tests. For example, one that verifies that the editor starts as intended, and that all the menus and features of the engine of the editor are loaded correctly. This also contains our custom written tests, automation tests. It allows control over the testing sessions. You can specify a number of each test, how many iterations do you want for it to execute. Yeah, and it displays whether or not a test has completed, failed with warnings and errors, and completely failed. It hasn't even started. So the first type of tests you can make in Unreal Engine 5 are functional tests. This one is the real icon. It's not photoshopped. You have to place a functional test actor in the level, and you can assign blueprint logic to it to verify certain actions. So it contains all of the logic that you can describe in a normal actor, plus a few test functions that verify the condition for success, for failure, and intermediate results. They are good because they can be integrated into a specific level. And you can, if you are familiar with blueprints, you can easily write a simple piece of code that would work. But it does not follow well with the logic that you have in your game. So, for example, if you have a game where your character is jumping on platforms, you may integrate a specific functional test actor to verify that that an actor with specific jump can jump on that platform, but these are not the rules that you have implemented in your game. So yeah, a piece of code, functional tests. Okay. Yeah, these are the unit tests. The unit tests are now not scripted in blueprints, but in the code. These are a foolproof way to perform an API check. So you can test your custom types and see, for example, if your custom number types are correctly converting one to each other. It does not require level loading, and they are made to run fast. There is a special category of unit tests that are called smoke tests that are made to be run really fast, less than 1 second for all of the execution of the tests, and they are run every time the Unreal editor starts. So these can be used just to verify that the preliminary pieces of running your code in the editor are completed. The bad thing is that they, again, are not so much related to the game context, just a piece to verify that your code is working well. Here is one. No, those are the feature tests. Feature tests are the most complex tests that are available in Unreal Engine 5. They are the tests that can create some setup. So for example, you're using the automation to open a specific map to load a certain level. And then you may specify whether the level runs at a normal speed or not, and some other things. But you basically load a specific setup and then perform your actions there. For example, you can start record performance stats there at a specific moment of your choosing. What are they good for? They're mainly good for performance tests. As I said, you can start at a specific point in the game. And if you know that, for example, at the end of the first round, something breaks in your game and the game crashes, or the performance is too throttled and the FPS is increased highly, and you cannot debug on that specific problem why that happens in this specific moment of time, you may record that and check in this good graph on what happens on the game thread, how much are the calls, is there anything that is off budget. There is the same thing for network tests to see that to see the bandwidth load, the number of actors that are replicating, and some data about them. And for the test scenarios, now these are the tests that we use to test specific game situations. There are a lot of examples there, but they all involve spawning a specific actor, giving it an AI behavior to perform a specific task, and then see the results of that task. In the first example, we are spawning a character, and we tell him to execute an area of effect skill. Now, we can check, these are all AIs, we can check if the skill manages to damage them both, so that the area of effect is really working. We have also an example where we can test the aiming system of a character, where the aiming reticle is pointing at the correct target. Currently it is not. And we have a test that verifies very, very specific game situation. For example, what happens when a character dies and another event happens at the same time. So we have a character that is constantly doing damage to himself and dies, and we are implementing other events that happen at the same time and see if they will break. This is especially important in a tag team game where the death of one character have to trigger switching of the other character in, but sometimes if it doesn't trigger, then that is a bug and we have to see why. Yeah, we have also autoplay setups where all of the characters that we have spawned are playing the game against themselves. So they are doing one quick PvP round or a big never-ending hours game. And we can see the results of that game. We can not only see it visually, the execution of these tests can be monitored by one that sees them, but we can also see the logs for that and check are there any major crashes, for example, after we've set the test to run over the weekend. One thing that these tests are really good for is testing regression. So if you know that your previous build has run without errors and the following one has some, you may investigate why. These are good also for map traversal scenarios and things related to level design, because you can easily put a single character to go over all of the map and see whether he'll get stuck somewhere or not. Yeah, and navigation issues, whether he can go over all of the map. You can test whether the preset AI behavior that you have given to your bots is good or it has some issues. For example, they just sit and don't do nothing. And you can test different types of AI. For example, you have said that, yeah, it will give the bots a hard difficulty by adjusting their settings and see how exactly this is harder than medium difficulty. Just get a simple statistic of that. You can also test game balance by spawning a few characters on one team on the other side, spawning a few characters of the other team on the other side, and then have them face against each other. You can easily adjust the values of their skills, of their stats, and see how another iteration of the same test would help you determine are these nerfing changes or buffing changes. And a summary of the feature tests. They are very, very accurate with the right setup. We've had instances where we are launching quite old tests. For example, we are launching an old test 1 year later, and it helps us determine that the issue is there. These are the best way to measure performance, as we said, and the advantages with running multiple iterations of the same tests on the weekend are there. Unfortunately, they require a lot of setup, not only in code, but in thinking about how to set up this scenario. For example, if you spawn a character and you have to test whether or not a fireball would hit him, then you have to place it in the right place and check the properties of the fireball. Would they really hit the character? It requires careful time management through asynchronous commands. Let me just go back. Yeah. All of these are latent commands, all of these. And the thing about them is that they're asynchronous. So all of the code executes itself synchronously. And once you start writing asynchronous latent commands, then you have to think about how to order them in the way that you want. For example, you want one character to spawn, then after 3 seconds, he would have to cast one ability. Then after 3 seconds, or other period of time, you have to check whether that ability has hit the target or not. And these are all things that you have to think about carefully even before completing the test. Yeah, and the last thing is that Unreal hasn't done a good job of writing good documentation on the automation settings, and lots of the features there are hard to find, and you have to find them in the code. Yeah, it's hard. It's hard to do sometimes. So, um, automation testing has certainly its advantages, and a lot of the tendency in the previous years uh, was to have mainly manual testers. A lot of manual testers that check every aspect of your game. Automation testing is slowly making its way in the game development, and the benefits are there. Both the Dalek Entertainment and Rare have really good presentations on the topic of how they have set up their automation system. The Dalek Entertainment with their great game World of the Rings Golem that is not released yet. The Dalek have set up a GitHub repository with their free, open source automation system made on Unreal, and they have some very good examples there. But yeah, this is an effort taken by them to expand the currently existing Unreal Engine system. Rare are also a good example where they have, I think, data on how they've sped their testing by maybe 40% by using only automation tests. And that is it. Any questions?
Yes.
Does Unreal support automation testing of the UI?
Not really. They have something called screenshot comparison, which doesn't work very good. But the thing with testing the UI is that at least it is deterministic. So you can...
Depends on the game. Depends on the game.
Yeah, depends on the game, but in most cases it's deterministic. At least the out-of-game UI. So the menus you can see that after pressing one button, it will lead you to this menu, and this is in all cases. Well, in-game UI is a bit more complicated, yes, but at least it conforms to quite well-defined rules. So you can use something like Selenium maybe or other visual testing tool to check your UI.
Okay.
Hello. I have a question. Can you guess player behavior with this? Because all the units that you talked about will still act with predetermined AI, but the players themselves sometimes push the limits, and some people even go looking for these errors. How do you deal with those? How do you guess the player behavior? Do you have some things that these people can do these things? Like you're guessing, they can go there to check it. Do you have those kind of brainstorming? How do you deal with that?
Okay, so mainly before our game comes into contact with people, we are preparing tests in development to see if some of the features work. After we have tested it with people and seen the issues they're having, we usually would have a specific situation that we know that they're breaking. So you something similar. Oh, okay. So you set up something like that with a limited automation test scenario, and you try to replicate in some form what they're doing.
Can you guess well though? Because players are always looking for these little errors or like some not finished places.
Well,
that they think it will be an error and it will make the game look bad in the process.
well, at first you have manual testing to verify some of these things, and secondly, yeah, you just depends on the situation. In cases where it requires multiple iterations, where it has to be scripted, automation testing is probably better. Yeah.
Questions? No, no, no. Yes, yes, yes. We have.
Hi. What advice would you give to a studio that, let's say, has an in-house engine, doesn't use Unreal? They've already started the project, let's say, in the pre-alpha, but they want to invest in automation. They want to start automating their project. What advice would you give that studio? Because it's still a big investment. Yeah, so it's still big investment. They have manual QA. So how do you convince them, yeah, you should invest in automation, you should start from here, start slowly building up, invest in these years leading up to the release of the project?
So first of all, I would carefully consider what game we are having, what parts we are able to automate. Maybe prepare a list of the different game systems and how they interact with each other. I know it's a hard process. Like we've tried something like that, and we have seen that in the situation where a character is throwing fireball at the other, there are more than 100 combinations of the different game systems and how they interact with each other. But at least if you prepare a list of roughly what you have in the game and how it would work, then you may decide for yourself if it's worth automating or not. Yeah, repetitive tasks are a good indicator of one such thing. I would say that scripting something like that for custom engine wouldn't be that hard, but the question is, would it be more useful than manual QA, and would you find the people that can do it and are willing to write such scripts?
Thank you. Kind of like a follow-up question. So once you implement your automation solution, how often do you see examples of it needs maintenance? Like you implement a new component of the game and suddenly your old automation scripts break. So how often do you see that?
I would say at the moment you are making your usual manual tests to verify that your game is in a good state. For some people, for some companies, it's once every sprint. For others, once every 1 or 2 months. But these are scripts. Once you have scripted them, they're ready for you to play them. Just play, execute, set the correct number of iterations, and you're good to go. It is true that sometimes the scripts also break with the iterations of the game, but I would say that the maintenance is minimal.
Okay, more questions? No. Okay, thank you.
Thank you so much.